This is the student peer teach problem, Unit 6 Study Guide, Problem 10. Remember, as you are coaching this problem, you need to ask more questions than narrate answers. Dialogue with your classmates, not dictate answers. Get them to ask questions. But before you can do your problem, we need to recap a section in your study guide. So find this section in your reference booklet. Find this section in your reference booklet, Proofs on a Coordinate Plane. We're going to go over this. You don't have to teach this to your classmates. This is included in everybody's video. Proofs on a coordinate plane. The first one, when you a midpoint equation will show if something's been bisected or has a common midpoint. That's the midpoint equation. The midpoint equation will show if something is bisected or has a common midpoint. The slope equation shows how a line tilts. Parallel lines have slopes that are equal. Slope equals slope. Perpendicular lines, slope times slope equals -1. The distance equation shows comparative lengths. It can show how two lengths are equal in measure or how they are congruent. Now, knowing that, let's take ourselves through a very simple proof here. We have a quadrilateral ABCD and we want to prove it's a parallelogram. So we're going to write out the basic 5 qualities of a parallelogram. And we get opposite sides which are parallel, opposite sides which are congruent, opposite angles which are congruent, consecutive angles are supplementary, and diagonals bisect. Those are the 5 main qualities of a parallelogram. If you can prove any one of those, you know you have a parallelogram. So let's think of this logically in terms of midpoint, slope, and distance. If I wanted to show that opposite sides were parallel, I'd have to use slope, because slope would show parallel. And I'd have to use it 4 times. Recap. Slope equation, y minus y over x minus x, rise over run. And in this case, I'd have to do this times 4 to do all 4 sides. If I wanted to show that opposite sides were congruent in length, so the length of AB and DC congruent, and the length of AD and BC congruent, I would have to use distance equation, because distance shows length. Remember, the distance equation is giant square root x minus x squared plus y minus y squared. And I'd have to do that 4 times, all 4 sides, to prove that opposite sides were congruent. Or I could prove this last one, diagonals bisect each other. So the diagonal AC and BD, to show that they bisect, I'd have to show that that point right there is a midpoint going both ways. and I would have to use the midpoint equation. Which is, midpoint equation is add the x's, divide by 2, add the y's, divide by 2. There's a fourth way, and it basically says if the same set of sides are both congruent and parallel. So if I were to show that these were parallel using slope, and so the same set of sides were congruent in length using distance, then I would have a parallelogram. Now, seeing how midpoint, slope, and distance works in a parallelogram, let's take a look at your problem, which is problem number 10. First, we're given a quadrilateral, TUNE. This one we actually have to graph, so let's graph it together. T is at 0, 10. And U is at 4, 2. And N is at negative 2, negative 1. And E is at negative 6, positive 7. Our goal is to prove that TUNE is a rectangle, so that's our positive. Yes, it's a rectangle, but it's not a square. So we actually have to prove both, one in the positive and one in the negative. So you ask yourselves, what are two key qualities that make a parallelogram a rectangle? What are two things that make a rectangle a rectangle? One, and the most obvious, is the fact that you have 4 right angles. So if you have 4 right angles, then you're going to have a rectangle, of course. And you ask yourself, using midpoint, slope, or distance, how could you show right angles? Well, right angles are the product of perpendicular lines, and that's a slope issue. So you'd have to find the slope of all 4 sides, and that's going to show perpendicular lines, and therefore it's a a rectangle. Or another thing that's unique to a rectangle, draw on the diagonals. And we know in a rectangle, the diagonal lengths, the length of one diagonal, like E to U, has to be the same as the length of the other diagonal, T to N. The diagonal lengths are congruent. And that's going to make it a rectangle. And if I were to do that, I would have to use the distance equation. Now, you don't have to do both. You do one or the other. In the distance equation, I would find the distance of those, show that they're congruent, and that we only have to do twice because there's only 2 diagonals. That's going to prove that, yes, either one of those is a rectangle. You have to choose which one. Now, we need to disprove it's a square. So you have to think about, here's a rectangle, and here's a square, and how are those not the same? That's what you're thinking there. Now they are the same with right angles, but a square has 4 equal sides. A rectangle does not. A square also has diagonals that make a right angle, and a rectangle does not. So to show the sides are not equal, I'd have to do the distance equation times 4 all the way around, and it would prove that that's not a square. Or I can find the slope of the diagonals, which is times 2. And then I would show using that the fact that they're not perpendicular, and if they're not perpendicular, it can't be a square. So it's one or the other, not both. You have to choose which way to prove, yes, it is a rectangle. It's one or the other. And then you have to disprove it's not a square, either by distance 4 times or by slope with the diagonals, and show that they're not perpendicular.